Okay, I'd like to Mark Weitzman again. I'm back with relativity problems, and let's do some simple kinematic problems from Feynman's exercises on physics. So in problem 13.6, I'll read it to you. A body of mass m at rest in the laboratory disintegrates into two parts of mass m1 and m2. Determine relativistically the kinetic energies T1 and T2 of the disintegration products. So it's very simple. We have a rest mass m, and then we disintegrate into two particles, each of which have rest masses m1 and m2. So, okay, let's work this out. We know that momentum is conserved. So the momentum before was 0 because the particle was at rest. So we're going to get that the magnitude of P1 is equal to the magnitude of P2. And P1 is the vector. I usually leave these out, but I'll put them in case you're confused, because there are 4 vectors in relativity. These are 3 vectors. So we know that using the usual E squared equal P squared plus M squared, the Einstein relation. And again, working with C equal 1. And so we have E1 squared minus M1 squared equals P1 squared, which is equal to P2 squared, which is equal to E2 squared minus M2 squared. And we know that not only is momentum conserved, but energy is conserved. Let me switch the pens so you can see it better. Energy is conserved, so that implies that E1 plus E2 equals M. This is the energy before, the rest mass M, and this is the energy of particle 1, the energy of particle 2. So now let's just, in this equation here, substitute for some values, and so we get E1 minus E1 squared minus M1 squared is equal to M minus E1 squared plus M2 squared. Nope, something's wrong there. So, if you expand this and do some cancellations, you'll get E1 is equal to M squared plus M1 squared minus M2 squared over 2M. And the definition of kinetic energy is the relativistic energy minus the rest mass. So subtract M1 from this expression, it's just algebra, and we're going to get T1 equals M minus M1 squared minus M2 squared over 2M. And the analysis works exactly the same for E2, symmetric, we just switch 1 and 2. So E2 is M squared plus M2 squared minus M1 squared over 2M, and T2 is equal to M minus M2 squared minus M1 squared over 2M. Okay, so we will use these equations in subsequent 3 problems in particle physics. These were particle physics from the 50s and 60s, but still useful to know. And we'll calculate energies needed to produce certain particles, but basically we'll be using these formulas a lot. And I'll see you in the next video. Thank you very much.